Hello everyone, welcome to our channel. In this tutorial, we are going to learn about agents, agent architecture, and how we can make use of LangGraph in order to create agentic GenAI application. So let's start. So what is agent? So when you think about agent is something, it is a system basically, which we call it a task, okay, do me this thing or I want this, etc. An agent takes your input and does everything itself, is a fully autonomous agent. It does not rely on human intervention, although a minimum human intervention might be needed in order to understand whether the human really like that input or not, or want to go ahead with the with the processing or not. So this kind of input is fine, but if we keep on involving with how the agent is working in every step, then it is a very loose agent, very basic agent. For example, if you create a chatbot using very simple chat OpenAI or something like that, it is not exactly an agent because you are simply giving it a very raw task, very simple task, and it will return the result. It normally, when we go to the chat GPT, we search for a query, we ask something, it returns. So it is not exactly an agent, right? So it's like a chatbot kind of experience. But what is agent is, we give a task, like suppose I want to book a movie ticket of a very popular movie. Okay, now we want to give this task to agent. So finally the agent, what will agent will do, agent will search over the website or using the LLM, and then keep on finding and able to find out the movie. And then maybe out of 10 it will ask input from user, okay, which movie you want to book ticket for, and then it will go through a different agent and then move book a ticket for you, and then you will be doing the payment, right? So most of the things are handled by agent itself. So maybe a single agent or maybe multi agent, but the task is more or less autonomous. So we are heading towards that by using this pre-built implementation of agent by LangGraph. Okay, so if in this diagram, if you see, we have the left hand side is a very basic agent where you ask an agent, okay, decide the route. Basically, if you write two function and that two function is based on a condition, okay, and you want that condition will be determined by the LLM itself. So if you want to do such basic task, you can make use of it, but that agent is more or less very basic and router based agent. Okay, but if you want that agent itself do everything, that agent will talk to LLM and then it will continuously do it in a loop, and we are going to supply certain functions as a tool to the agent. Then it will be basically a fully autonomous agent. Basically, agent keeps on sending the request to the LLM and then make use of the tool, and if the response is not expected, then it will again make a call to the LLM. So it will keep on happening until the final response is prepared by the agent. So then that kind of agent is known as fully autonomous agent. So we have like very less control in case of router based agent, and then we have more control in case of fully autonomous agent. Okay, so let's understand what is this ReAct agent architecture. Okay, what is the basic agent architecture provided by agent architecture implementation provided by the LangGraph. ReAct is basically a reference specification which is provided by arXiv in this white paper website arXiv, and they talk about the agent specification. Okay, what is an agent should be able to do, what kind of implementation we should provide, etc. So how the LangGraph actually come up with a solution, they implemented this ReAct reference specification, basically white paper, and but there is some modification they done, and they reasonably put down points on their website on the documentation that they have reasonably implemented that is a pre-built ReAct agent. Okay, so this is a LangGraph pre-built ReAct implementation. Okay, before we go towards it, so what are the core concepts of ReAct agent architecture? Planning, tool calling, and memory. Basically, planning is like how the interaction will happen with the LLM and with the tool, so that the final outcome can come. Tool calling is like supplying the tool. Tools are nothing but normal functions like Python functions you create or any Node.js functions. You supply it as a tool to the agent, and agent will make use of the tool basis on the requirement. Okay, if the LLM is not able to give the response, or then we can make use of the tool. B means like agent make use of the tool and accordingly prepare the response. So this is tool calling. We have covered this in one of the video. You can go and understand the tool calling in depth in the last videos. Okay, so memory is like keeping in context, like suppose a conversation happen and a second conversation begin. So memory is like it will keep a check on what is my last conversation, and basis on that I'm going to respond back. Okay, so memory can be short term memory or a long term memory. Okay, so we are going to cover up the short term memory in this tutorial. Okay, now how the interaction of the agent with the LLM happen by the pre-built agent. So LangGraph pre-built agent React implementation, what it says, suppose you provide an input to the agent will make an LLM call, okay, and get the response, and then it will make use of the tool. Like in the response from the LLM, it comes as like which tool to call, what are the argument of that tool, and then agent will make a call to the tool. Tool is nothing but function, and with the specified arguments, whatever the arguments written by the LLM, it will make a call to the tool. If the tool is not able to fulfill the response, it can again make use of the LLM call or make use of the another tool. Okay, so it keeps on happening in a loop and until the final response is prepared. So this is how the pre-built agent given by LangGraph works. Okay, now let's understand what is the basic code. When I say pre-built agent by LangGraph, it means you can think of it as pre-built function given by LangGraph to create an agent. So what is the function name? Create React Agent. Function name is create React Agent, and these are the parameters which we can supply to this function. And I mentioned a few of them. There are more. Okay, I mentioned the important ones here, like passing the model, like which model to use, Open AI model or Gemini model, which model you want to use. And then tools, like it is an array of array of functions. We supply this in this tools argument, and then check pointer will make use of the memory. It is up to us if we want to use the memory or not. Otherwise, it will not make use of the memory if you do not supply. Prompt is if you want to supply the prompt explicitly, okay, along with whatever is happening, like agent, we can give the explicit prompt message to it. Response format is like final response. What is the final response format structure? Like you want to capitalize the structure, like response, you want to make change in the final response, the way the English is been presented to you. Whatever is the final response format, we can supply, like schema, etc. Interrupt before, interrupt after, these are used in case if you want to use human in the loop, and you want to interrupt before agent makes a decision, like before making a call to the tool, it can ask from the human, us basically, like whether to call that tool or not. Okay, so that way we can make use of this interrupt before and after. And there are other arguments as well, like supporting multi-agent architecture using this create React agent is also possible by having another set of arguments is possible. Okay, and then we can simply create an input. Here the important thing is that the state schema that we understood in LangGraph is always has a state, and which has state structure, right, which is dependent upon us what kind of state we want to supply. In the create React agent, basically the state schema is already defined by the LangGraph itself. The structure of that state schema is messages colon list of base message. This base message is nothing but AI message, human message, all those message classes are derived from this base message class, and this class is present in the LangChain package. Okay, so messages array is basically the state schema, and similar in the initial input what we are supplying the value of this messages array. How? Like user comma, suppose my query is current time is, okay, so this input we are going to supply to this agent. How? Graph.invoke inputs. So in this way we are going to invoke this agent. Now you ask question, okay, we have created an agent in the LangGraph explicitly, like we have created state graph in the last video, right? Nodes, edges, etc. And then we are able to get the answer. But here we are not doing it. Everything is done internally by the create React agent. You don't have to worry about it. You just have to supply the input, and final responses provided by the LangGraph. You have to just make sure that you supply the enough set of tools basically in order to make the agent work for you, and then finally the response appears to you. Okay, so let's understand this in a VS Code, in working code in the VS Code. So this is a setup using UV package manager. I have set up this code. We are making use of this repository. It is public repository, so I mentioned the link in the link description basically. And then here we are creating a react agent.py file. So in this Python file, the basic code is written. Okay, so here we are using chat OpenAI, chat GPT model, GPT-4o, and OpenAI API key, initializing it, the model. And then this is the small function that we have created, get weather. Basically, it says that if the city is New York, it might be cloudy in New York. The city is San Francisco, it's always sunny in San Francisco. Okay, and otherwise it will give the assertion error. So this function we have provided it is as a tool. So here @tool is mandatory to signify that this is a tool that we can pass it to the agent. Okay, and then we are creating it an array, tools equal to putting it in the array, get weather in an array, and then we are creating an object of this create react function. This we are calling this function basically create react agent function, passing in the model and the tools. Okay, and the initial state is, as I told, messages array. Okay, and then we are supplying the messages as an input. User, what is the weather in San Francisco? Okay, so then finally we are invoking it, graph.invoke inputs. Now what we are doing it over here in the print statement is that this will be a conversation, right? When the conversation happen, this messages array is keep appending the messages. Okay, so the initial message is human message, and then it interacts with the LLM. So LLM respond back with the AI message, and then AI message will contain the information about the tool, like which tool it can call, because AI, when we supply the tools basically, so AI will see if the AI will see that if we have the tool, then it will not be giving you the response of the weather, because this is the weather we are asking in terms of current condition. And then because of that, it will make use of this tool that we have supplied, and then this tool will get invoked, and then again the response of that invocation will go back to the LLM, and the LLM respond again back. So basically these are the states: initially the human message, then human message AI message, because AI message will return back with the tool information, and then we have a tool message. Basically the tool gets invoked and we get the tool message, and finally we get the AI message. Okay, and that AI message is finally be printed over here, because AI message is the last message. We want to get the last message. We are using response of messages of -1 is like last message from the messages array, and then we are printing the content. So this is how the entire code has been written. And if we want to see the invocation of this code, we can click on UV run and this particular path of this file, and then we are invoking it. Okay, the weather in San Francisco is currently sunny. Okay, so this is the implementation. This is the usage of the pre-built agent provided by the LangGraph. Now what else? Like if we, in this case, if we are invoking it with graph.invoke, we could not see internal steps basically, right? We only see the response. If you want to see the internal steps, like internal different interaction with the LLM, with the tool, etc., you need to make use of the stream mode. Okay, so if we want to make use of the stream mode, like let me just comment this one. Okay, and this is the stream mode approach. So in this stream mode approach, basically, okay, so this is the stream mode approach, where what we are doing it print stream. Basically we are using, instead of using graph.invoke, we are using graph.stream, and then we are passing the inputs, whatever is the input we have, right? So we are passing it here, and then we are making use of stream mode as values. So what values means that it will print, basically it will give the chunks of each state change. Okay, every time the state changes, it will actually fit it as a stream chunks. Okay, so for S in stream means what it will actually, S will contain first this, and then this, then this, means each state change it will contain. Okay, so here what we are doing, we are getting all these chunks within this stream, and we are printing it. So with this approach, we can see what is happening internally within the ReAct agent. Okay, so that is what the beauty of this stream mode. Okay, if you want to see state changes at each step, then we can make use of the stream mode as values and use graph.stream and pass in the inputs. And this is a small utility function which makes use of the stream and looping over the stream, and then we are printing it. Okay, now this is about the ReAct agent. So instead of using this function, like this is a very basic function, get weather function, instead of that you can make use of your own function. You can have a function like, okay, book me a ticket, or you can have a function like generate a report, or read a PDF, export a PDF, whatever, like do a data analysis, or you can say customer support, etc. You can have various tools, tool 1, tool 2, tool 3, and you can supply it in this array, and then accordingly the agent will interact with the LLM, and then basis on the response from the LLM, the agent will make use of the tool, and then finally you will get the final response. Okay, so we'll see the multi-agent interaction in the upcoming video, but in this video we have covered up this pre-built agent, how we can make use of it. But apart from this, if you want to use the memory, like you want to make sure that it will remember whatever the interaction happen. Suppose in this case, if we are not using any memory, right? We don't use any memory. There is no argument of check pointer we are using here, right? So what in case if we are going to invoke this particular line, suppose if I uncomment this, if we want to invoke this line, so what will happen that what's in known for, so it cannot recognize the previous interaction. So it says that, hey, I don't know what you are asking for, right? But if you use the memory, then it will make use of, okay, you have asked earlier about the San Francisco, so let me give you the information about the San Francisco. How this could happen? This could happen by using another, like we have created another code which actually has the memory related stuff. Okay, so what is extra here is memory saver. We have imported a memory saver from LangGraph. Okay, and then we are passing as the last argument check pointer equal to memory. We created the object of memory saver, and then we are passing it check pointer third argument memory as a third argument, and then we are, while calling the graph.stream, we are passing the, there is one more thing, we created a configuration, config equal to configurable thread id equal to 1. Thread id is like, thread id is for each conversation, right? For each conversation, like this is a conversation we want to keep on happening. Like for example, you are doing the ChatGPT interaction, you keep doing the ChatGPT interaction continuously, right? You can come back again and go from the chat history and again continue the interaction, right? So we are giving an ID so that this ID will uniquely identify our chat history. So first we do the initialization of the memory, then we do the configuration, and then we are passing the memory as a checkpoint or third argument, and then we are making use of the config as a second argument in the graph.stream. Okay, and that's it. Now with this input, with this approach, if we are going to ask again what's it known for, then it will be able to recognize, okay, you have asked for San Francisco, let me give you the answer about the San Francisco. So this way we are able to see the usage of pre-built agent by LangGraph, how we can implement it, how we can make use of the memory in order to recognize the last conversation. So I hope you understand the concept of pre-built agent, and let's see it from the eyes of workflow as well. Like pre-built agent, as I told, user gives the input to agent will go into the loop with the tools. Okay, it will go into the loop with the tools. It will first make an interaction with LLM, and then it will make a call to the tool, interact it, and finally it will give the response back to the user. Okay, this is how the pre-built agent works. Okay. So we'll cover up the custom agent in the upcoming video and about the multi-agent interaction as well. So stay tuned with us. If you do not want to miss such videos in the upcoming series, then please subscribe to this channel, like this video if you really like it, and comment on this video if you have any queries further. Thank you so much for watching this.